Hello everyone, this is Nilesh Gule here once again. After learning object-oriented programming, now it is time to talk about the very important concept called as exception handling. When we are dealing with any real-world application, at runtime, we can expect some sort of problems. And these runtime problems are represented as exception. Exception handling is one structured way of dealing with these errors. This is available in almost all object-oriented programming languages, including C++, Java, Python, and others. What exactly the exception is? As I said, exception represents a real-world problem, and the common reason or common errors that you see at runtime could be invalid user input. Let's say you want to do division of two numbers, and if user enter denominator at 0, then this application will fail at runtime. Another example could be the programming mistakes. If you had already started the C# programming, you must have come across null reference exception, where we forgot to initialize the reference correctly. Another example could be we are doing some sort of a file IO, and the file that we are trying to open doesn't exist. So the resource that we are looking for is not available. This can also cause the runtime problem. And another common reason of this problem is my application depends on the external systems like database or some other website. And for some reason, that database server or website itself is down. So my application will fail with the runtime error. Whatever is the reason, if exception occurs in the application and if I didn't handle it, then application will crash and it will show me some error message. If at that time some data is present in the variables, that data will be lost. And to write the robust applications, it is always good idea that we can think of what kind of problems might occur and we should be ready for handling those problems. That is all about exception handling. What exactly the exceptions are seen in a programming language? So you'll find that in object-oriented programming languages, exceptions are represented as objects. And in C#, you'll find that these are the objects of some specialized classes, the classes which are inherited from the system.exception class. There you see the list of common exception classes, and you will find that many of the CLR inside exception are inherited from system exception class. That itself is inherited from system.exception class, whose base class is system.object class. As I said, the common exceptions that are known to us are like null reference exception, or I'll show you in demo, we can have divide by zero exception. Note that it itself is inherited from arithmetic exception. In case of wrong arguments passed to some function, we can get argument exception error, or we are trying to access the array element with the wrong index, that will cause index out of range exception. As I was telling you, you are trying to open a file that doesn't exist, that will be file not found exception, which itself is inherited from the IO exception. Of course, there are such many different exception classes. I have written only the few one. And as we go ahead, as far as our application is concerned, there might be the cases where we want to write some exception which is specific to our application. Talking about like invalid order exception or wrong payment exception. If that kind of application specific exception classes are to be written, then it is recommended that our classes should be inherited from the class called as the application exception class. As we will go ahead, I will also demonstrate it. Let me quickly show you a quick syntax and then we will look into the practical. The basic syntax of the exception handling look like this. So if we are writing some sort of a code which we believe that it may fail at runtime, some risky code, then we should put it into the try block. Now this particular code might go wrong and it may throw some exception. That is the reason we are trying out that code. If any exception occur, then we should be catching that exception, and then due to that exception, whatever problem might be occurring, we should be in a position to handle that into the catch block. There is also one important block available in Java or C# like finally block. When exception occurs, at that time catch block will execute. If exception doesn't occur, the try block will execute successfully, but the finally block will be executed irrespective of whether exception occurs or not. Please note that writing catch as well as finally both is not compulsory. But one thing is sure, whenever you are writing a try block, it must be associated with either a catch block or a finally block. You cannot have the standalone try block only. Let me give you some actual examples so that you can understand it better. So I have already created one project, a simple console application, and into that we are having this hello world in front of you. Now let us consider a very classic example of exception handling. Let us take two numbers from the user, divide them, and whatever is the result, let me print it. So how we can do this? Let's say I'm asking user that you enter two numbers. That can be done simply like enter two numbers. Then I want to have a numerator. Talking about, we can like console.readline and we are converting it into the integer. Then I will have another number, let's say denominator, and again I'm reading that string, converting into the integer. Then I want to do actual division. So this division at this moment I'm considering integer divided by integer gives me integer. I'm not going for the floating point. Let me run the application and you can check. Let's say I have 12 in the numerator, 3 in the denominator, result is 4. Everything is going fantastic. But don't you think that this might fail at runtime if user give a wrong input? Like if user enter 4 and denominator is 0, this is going to fail the application, and you can see that yes, it is causing divide by zero exception. But due to that, my program has been crashed with such kind of weird error message. Now this is not something I should be showing to my end client. So I should be trying this code because we know that this code may fail. This is a risky code that I was talking about, which should be put into the try block. And as I say that you cannot have the try block alone. You have to write either a catch block or you have to write the finally. For time being, let me write the catch block. And in this particular catch block, let me just ask user that some error occurred, something like this. Let me run this. And now you see that if I'm giving the correct input, I'm getting the correct output. So only try block is executed and nothing from my catch block is executed. However, when I run the same program once again, and then I pass 0 in the denominator, now my application fails and it directly jumps to something went wrong. I guess this gives you clarity. I just want to debug this program once so that you actually see the flow of execution. So let me use F10 and then I'm taking the input one by one. So again, I'm saying F10, the first input, let's say 12. Again, F10, the second input, let's say 0. Please pay attention. Here I'm trying to do the division, which is of course going to fail. And moment it failed, it directly jumped to the catch block, skipping the statements remaining statements from the try block. So whatever was written after that exception point that was not executed from the try block, and control directly jump to the catch block. And then we can see what is executed is the statement written inside the catch block. If I had written some code after that try catch, then that code would have been executed. Currently, nothing is executed and my application is terminated. So this gives you clarity how exactly the basic exception handling is to be done. But in this case, I'm not able to print any information about the display error. So how I can have that error information available? For that, you have to catch the exception object. How do I write it? Let me copy this block code and comment the existing main. And in next main function, I will write the same code once again. And over here, I will write the catch block where I will get that exception. And then whatever error that I'm seeing over here, this particular error, let me display it by saying e dot toString, or you might also say only e over there. So if I run this full application and again purposefully I'm entering denominator 0, what happened? My application fails, and then this exception information then printed on the screen, because this exception information was available in this exception object. You already noticed that the object was DivideByZeroException object. Since exception is a base class, I could catch that particular exception. Okay, that is again a very simple and straightforward example. But don't you think that there are other possible problems in the same application? Let's say, what if the user enters the wrong value altogether? Like instead of entering the digits, what if user enter the number 10? You know that now this 10 cannot be converted into the integer. And if you try to convert, it will cause another exception called as a format exception. This is also one of the subclass of the exception class. Now, how do I handle and how do I show the separate errors for the number format or this divide by 0? Is it possible? Answer is yes. And for that, for one try block, I can write the different catch blocks. So I can have a separate catch block which is talking about divide by 0 exception. And inside this, I can specify the exact statement that you cannot divide by 0 or divide by 0 error. The more details, if you are interested in printing, you can print that exception object. Or for the similar line, I can also have like a format exception. And again, I'm printing it as a format error. And in this particular case, this error is more or less a general error. So if any exception occurs while division by 0, it will execute this catch block. And please note that it will execute only one catch block, not multiple ones. So in case of divide by 0, if denominator is 0, it will jump to this catch block. It will execute all the statements in this catch block, and then statement after the catch blocks that will be executed if we have written. In case if user enters the wrong input, let's say user enter TAN 10 over here. Now at that time, that TAN 10 cannot be converted into the integer, and that is the reason this convert.toInt32 will fail, and then control will jump to directly the format exception, and then whatever is written inside the block that will get executed. And if at all I'm getting some error which is neither format exception nor divide by 0 exception, if there is something entirely different error, then that error will directly jump to this exception, which is a generic catch block. And inside that, whatever logic is be written, that logic will be executed. So here you understood that one try can have multiple catch. You can relate it or remember it with some example like cricket. You see that in cricket we have like a one batter and then there are 11 fielders around to catch it. However, the reverse is not true. So you do not consider that you will have multiple try and single catch. One try can have multiple catch, but reverse is not allowed. Reverse is not applicable. Well, so this is one example that we talked about the exception handling. Now, I want to also show you that example of finally block. But for that, I'll take some different example. I'll have some good example. Let us talk about the actual file IO. Of course, I'm not really planning to teach you the file IO over here, but let us take the realistic example instead of just taking some dummy example. We will have a separate class where we will discuss the file IO in detail, but right now I'm writing a small piece of 2-3 lines of code of file IO, and we will see whether it will give me exception and how do I handle it. Let's consider this. Let me have one file present in the folder. You can just create the file, a simple text file directly from here, or you may create the file from your Windows Explorer. Right now I'm writing test.txt as the name of the file. And inside this, let me write some simple message like hello C#.net. Here I can say that this is simple file IO code and this may throw runtime exception. That's it. What I want to write a very basic level code which will read this file and then it will print the content for me. And then we will talk about how do I handle exception handling with this. So for time being, let me remove it. Let me find out what exactly the path is. Let me collect the path over here. So string file path is equal to, this is where I have written the path. If you are on Windows, please be careful of this double slash. Or if you do not want that, you can use, let's say, @ which represent the raw string literal. I have pasted the whole path over here. And then I want to use a stream reader. So stream reader is a simple class available which can help me to read the whole file data. And then there is a function sr.read to end that will read the whole string in the file where I will collect it into the text. Let me print it. So this is my file text is printed. Now don't you think that this file is external resource? So once my job is done, it is my moral responsibility that I should be closing the file. So you can close the file by using sr.close. There is also another function called as sr.dispose, but for time being, let me write this much of code and let me run my application. And you see that all the data that was written into the file has been read successfully. Everything went well. But what if the file path is wrong? If the file path is wrong, the same application is going to fail. And I was talking about the error called as the file not found exception. And that is the reason it has given me such a huge error. So how do I write a code where I will be ready for such kind of problems? How do I handle these errors? And that is where the exact try catch block will be useful. So let me write it simply like this. I'll put this block code which may fail into the try block. And after that, if any error occurs, like error like file not found exception, or for time being, let me write a generic error only, let's say exception error, and I just want to put a simple message saying that the error occurred or general error. I can print the error information over here. But now, don't you think that whether error occurs whether error doesn't occur. In both the cases, it is absolutely compulsory to close that file if it is already opened. So where exactly I can write that code? One way is that I can repeat the code into try as well as catch. So I might write the code like sr.close over here also, and then I can also write the same code over here once again. But it is unnecessarily repetition of the code. This is exactly where the finally keyword shines. This finally keyword is available into Java and C# kind of language. So we can write the finally keyword at the end, and inside finally keyword, I will have a check that if SR is open, then I should close that SR properly. Now let me run the application. And while running the application, I'll just do one thing. I'll also write one finally block console statement. Let's say finally block executed, so that you get the idea whether the finally block is executed in all the cases. Now you see that I got the general error, means catch block is executed, and afterwards the finally block is executed. That's good. But if the file path is correct, let's say test.txt, and I run the same application once again, then again I got like a finally block is executed, isn't it? So I just want to ensure it once again that finally block is always executed, except one special case that your application is terminated. The process itself is terminated due to environment.exit or environment.failfast. But otherwise, remaining all cases, the finally block is executed. Please note that even if you have written a kind of a return statement over there, even due to the return statement, you will find that the finally block is still executed, right? So this finally block is the most elegant way of handling the resources. However, many times people forget to write this final block, or sometimes writing this final block unnecessarily add another 2-3 lines of code, and your code may not be very readable. This is exactly where the .NET come up with IDisposable interface. I'm very sure you remember the IDisposable interface we had discussed in our interfaces class. So you can go back and you can look into that IDisposable interfaces. For the clean code of resource cleanup, you should use the using keyword. And very importantly, the class, the object that you want to clean up must be inherited from IDisposable interface. Well, how I can do that? Let me copy this block code and rewrite it using using keyword. Over here, I will take only try and catch. I will not write the finally once again. But instead of that, what I'll do is I will use the using keyword, because the stream reader class itself is inherited from IDisposable. And after that, I'll just close this. Please note that I'm nowhere calling sr.close, but since the IDisposable dispose method is implemented into the stream reader, at the end of this using block, internally it will call sr.dispose, and that sr.dispose will automatically close my open file. Let me run the application and you can check that it is still giving me the same result. Please note that in this particular case, it is guaranteed whether exception occurs, whether exception doesn't occur. This dispose method will be definitely called. When we will go for the file IO class, all the demos that we will write for the file IO, or even for that sake of database connectivity, we will always leverage this using block and IDisposable interface, because that is the perfect way of cleaning up the resources. And I strongly recommend that Nowadays, finally block people are not using that commonly for cleaning the resources. Now that you have already understood the try block, the catch block, also finally block, let us go one more step ahead and let me show you a simple demo. Let me first comment this particular code as well. And now I want to write a new class altogether. Consider that I want to write a simple time class which will represent you the hours, minutes and second, a simple time. So let me write a class time. And in this particular time class, as I said, I want to have three data members. One is hours, second one is minutes, and third one it is seconds. Now we can also write some sort of a constructor and we can also go for writing properties. Let me write the property first. Let's say the properties is hours, and in this property I can have a get part and a set part. In get part, let me return the hours, and there will be set part where I will set the value. But now, don't you think that in this particular case, you cannot really set any value into the hours? There will be some limitation, like the hours. If it is a 24 hours, if we count it, then the valid hours are between 0 to 23 only. If someone pass -2 or someone pass 25, 26, it should not be accepted over here. We also tried such kind of controlled access when we discuss about the basic OOP. But at that time, we have not learned exception handling, and that is the reason we didn't throw the exception. But the most appropriate way of handling such kind of controlled access is to validate the value, and if something goes wrong, then I should be throwing the exception. And what kind of exception I can throw? I can probably throw a kind of an argument exception. The argument exception is a built-in class, and in argument exception I can provide that message like hours must be in a range from 0 to 23 or something like that. On the similar way, the way we have written for hours, we can write it for the minutes as well. And into the minutes, again we will write the same sort of a getter setter, and again we will write the validation logic. If the value is less than 0 or greater than 59, then I will throw the exception. And the similar logic can be written for the seconds as well. Exactly same logic we are trying to write it once again. To display the time, let me write the toString method. So override, and I'm going for toString method where I'm trying to print hours, minutes and seconds. And then we can continue to write the other business logic. You can continue to write the methods for incrementing time or like any other things. That is okay. Let me try to call this. Let me create the object of time. Let us assign some value to hours, minutes and seconds. So let's say that I'll put hours is equal to something, and then minutes is equal to something, seconds is equal to something, and then I'm calling toString for printing it. So let me run this, and you see that yes, it is showing me the correct time. Everything is working well. But what if by mistake someone tried to give the wrong hours? Now there cannot be -4 hours. What will happen in this case? In this particular case, my exception will be raised, like argument exception, which is showing me that hours must be between 0 to 23. And since this particular class is written by me, I have enforced that anyone who try to set the state of my class object, it should be within some proper limit, within some proper range. If it is not, then I'm throwing the exception. Now, if my colleague who is going to use my class, if he want to handle this, then it will be mandatory for him to write a try-catch block, and inside a try-catch block, he should be handling that error. So whatever error it is there, it can put some sort of a general error, and it will be able to see the actual error over there. I hope you got the clarity how we can write the functions or properties, and inside that, if we come across some wrong input or some situation which is going to fail in future, then we can throw the exception explicitly using the throw keyword. This is where the throw keywords are used explicitly. But in this particular case, I have not written any new exception class. You see that argument exception is a predefined exception class, which is inherited from system exception, which is inherited from the exception class. But what if I want to represent my application specific errors? Is it possible that I can specify the application specific error? I want to make my error more readable and more understandable to my entire team. And that is the reason I can write my own exception class. As I said earlier, that exception class should be inherited from the application exception class. Well, how exactly we can implement it? Let me again comment this and let me try to use that code. So I'm commenting this time class and then I'm rewriting the time class where I will use the custom exception. But to use the custom exception, very important thing is I need to first write my own exception class, which I will write it over here. Class, let's say I want to talk about invalid time exception. And my class, I can write it inherited from the exception class, or recommended that I should be inheriting it from the application exception class. To implement this exception class correctly, I should be having a little understanding about the existing exception class. So you can take a look at the by default exception class given in the .NET. It is base class for all exceptions, directly or indirectly. And there are basic properties which are available in every exception object, which is nothing but message. So you will have a proper readable message, something that we were seeing like R's must be in a range from 0 to 23. Or this is stack trace, which was clearly showing you that where exactly error occurred and which function is called from which function. Apart from that, there is also one source property. That source property actually tells me where exactly that exception occurred. That particular exception is occurred in which project or in which assembly. And then there is also a concept called the inner exception. If my exception object is a result of another exception, if it encapsulates or wraps another exception, then this inner exception object or inner exception property can also be useful. To write your own custom exception, ideally, we should be writing our class inherited from application exception, and then usually we do not write many members, but at least we write a constructor from where we call the base class constructor, and inside base class constructor we try to provide some meaningful message over there. This is the minimum requirement that usually written into this. However, if you want that your exception class should hold something, the relevant data or some extra information, then that should be taken as a data member of the class. Now, over here, I'm talking about invalid time exception. Don't you think that over here we can have some extra information? If the time is invalid, why exactly it is invalid? Whether the hours are invalid, whether the minutes are invalid, or whether seconds are invalid. How do I get to know? So don't you think that here I can specifically mention that which field is wrong and then what was actually the wrong value? Let us try to consider that for this code. So we can have one thing, let's say which field is wrong. and later on, I also want to know what was the wrong value for that field. That's it. Let me write now the constructor. And into the constructor, I want to pass these two things. One is which field and which value. The name of the constructor is always the name of the class. Okay. But in this particular case, what message I will get? The message I will get is by default the message of the application exception. Now there are two ways. Either I can think of overriding the message property. So I can go to the override and then I can think of overriding this message property. This is one way. Or the better and more common approach is to make a call to the base class constructor, and typically the base class constructor takes a string as argument, and that string argument is basically the message. The way we pass that invalid argument exception, we pass a string like ours should be in a 0 to 23. So that sort of message we can provide to my base class, that is application exception, something like this. So I'm mentioning invalid value so and so value for field so and so. Now I need not to write anything else. If you at all need something for your application, feel free to add it over here. Now let me use this invalid time exception at all the places instead of only general argument exception. So I can use, let's say, invalid time exception, which is mentioning that the wrong field is ours and the wrong value is, let's say, value. Please note that we have taken the string for field and string for value. If you want, you can take value as an integer as well. That is your choice. Anyway, let us go for the second one. Over here also, I do not want to throw the argument exception. Instead, I want to throw invalid time exception. I will say that what is wrong over here? Something wrong over here is minutes. And then I'm also passing the value, the wrong value over there. Similarly, I can go for seconds. And in seconds also, I can mention throw new invalid time exception. I mention seconds and value to string. I hope that is all right. Let us try to run that application once again. And then we would check whether it is giving me the new exception like invalid time exception. So here you find that I'm sending the wrong hours. Let me run this and you'll find that it is showing me the invalid time exception. This is nothing but the exception defined by us, and this is a message that we passed it to the base class. You are able to see that the stack trace is already available saying that this error is thrown from line number 83. But that call of set hours was done from the main at line number 217, where that actual call was done at line number 217. Now this is similar way you can check it for the minutes and you can check it for the seconds. Please note that these kind of exceptions, the special application specific exceptions, they will increase the readability of the code. Anyway, now I just want to take it to the next level, and there are some important features like given in C#6. C#6 has got a new feature called as a exception filtering. So what I can do is you can have a same catch block or the same type, but in that type I can use some sort of condition and then I can handle the same exception into multiple catch blocks. Let me show you the demo. Let me just again comment this and copy it into the new main, where I will show you the different examples that hours exception we will handle separately, minutes exception we will handle separately, and seconds exception also we will handle separately. How we can do that? Let me just show you. In this particular case, you find that since I have written just an exception, so any type of exception will be catch over here. but I can also write it as, let's say, invalid time exception. This will show me the time error. But what if I want to show the hours error separately, the minutes error separately? How I can handle it? This is where I can use the when clause. And inside when clause, I can specifically check that the exception object dot field is equal to hours. Now you can mention any sort of condition over there as of your choice. It is not compulsory that you have to put the condition onto the field only, or you have to put the condition onto the message only. You can give the condition on any of the field. And again, the condition need not to be only equal to. The condition could be like, if it is a string, then you might say that, okay, field dot contains something like this. So that kind of check is also allowed. Let me check what is the data member of my exception class, and that data member is field. Currently it is not getting access because it was declared private. Let me mark it as public, and then it will be accessible over here inside the when clause. Now something similar I can go for the minutes and seconds as well. Currently, let me tell you the time hours error, and then I can write another catch block for the minutes, and then one more catch block for the seconds. That's it. And then at the end you might have like a general catch block as we were writing earlier. Let me run it. Over here you see that the hours are wrong. Let me see that now it is actually printing the hours error. But what if my minutes are wrong? Let's say minutes I'm putting like a 69. What will happen in this case? Let me debug and show you. Now in this particular case, it will try to have that invalid time exception, and that will be checked with the first catch block, and it will try to match whether the field is equal to minutes. Unfortunately not. So it will go to the next invalid time exception catch block, and over there it will try to match, is the field is equal to minutes? Answer is yes, it is minutes. That is the reason it will execute that catch block. And as I told you, only one catch block is executed, and if you have written any statement after that catch block, then that will be executed. Currently you can see the result that the time minutes error is printed on the screen. So this is how we can write a concept called as a exception filtering. Let us take a quick look at the basic exception handling rules. I have listed these rules over here. The first rule, the try must have catch or finally. You cannot write the try block standalone. The next, the try block may throw exception of any type. In our first code, it might throw the format exception, or it could throw divide by zero exception. And then it is our responsibility to write the multiple catch blocks where we can handle the specific exception. Though one generic catch block will be in position to catch all the errors, it is always recommended, suggested, best practice that you should handle each error separately and should take the appropriate action on that. The specific catch must be written before generic catch. So you noted that we had written the format exception and divide by zero exception before a simple exception, because the divide by zero and format exception, these are the derived classes, and only exception is a base class. So it should be written always as a last block. You can also write only catch without any exception object altogether, and that is again a generic catch which can catch all the errors, and over there you can only display the general error message that something went wrong, but you cannot get the information about the exception. You cannot get the message or stack trace or toString about that exception. Then when we catch any exception in the catch block, what exactly we can do? We can either handle the exception, which can include maybe printing some sort of a message, or which might be even exiting the application, or which might be asking user to re-enter the data or something like that, that kind of options. Or we can rethrow the exception. Means if I have written a catch block, the inside catch block, whenever I'm handling the exception, instead of handling or instead of like partial handling, I can write something called as a rethrow. So how exactly rethrow is done? For that, a very simple syntax suggested is write only throw followed by semicolon. This is considered as rethrowing the same exception ahead, and then that exception will be caught by its caller. That exception will be caught by its caller, and in this particular case, the stack trace which was available in this exception object will be retained. The same stack trace will be received by the caller. That's great. I already told you that exception, when occurs, it will skip the rest of the statements in the try block and it will jump to the matching catch block. That matching catch block might be present in the same function, or it might be present in the calling function, or maybe present in the calling to calling function. But somewhere, wherever is the nearest place, it will try to get that nearest catch block matching that try. And please note that in this process, if there are any local variables available in the try block, then these local variables which are created on the stack, they get automatically destroyed. These local variables which are present on the stack, those will get automatically destroyed. This is many times called as stack unwinding. However, if you have some resources like file or like database connection used in this try block, it is never closed automatically. And that was exactly the reason we were talking about the finally block, or as I told you, you can go for IDisposable or using keyword. And that was the last important point, like finally is always executed for cleanup. So you should be using finally, or you should be using the using block like IDisposable. Now, after learning so many things about exception, a lot of time people feel that exception is very powerful tool. Yes, it is powerful. And many times people tend to use exception everywhere. Like every simple program, they look for like an exception handling, which in my opinion is not good choice, because these exceptions are expensive. It takes extra resources to build that stack trace. So exception should not be used in your regular flow of execution. If you have something unexpected, something dependent on the external resources, at that time, exceptions could be a good choice, but you should avoid exception if it is possible. Like some example that I would like to give it over here. I'll take you back to my divide by zero code, and the same code we can write it one more time, but this time we will try to avoid exceptions if possible. How we can do that? Let me first copy the first code that we had written, and let us try to write the same code once again. Now in this particular case, we are taking input from the user and then converting into the integer, and which may eventually fail. You are not very sure about that. In this particular case, what we can do, how we can write the code better. Take a look at this. Instead of relying on exception, we can use the try parse pattern. What is try parse pattern? You will find that there is a function called a try parse available, and this try parse function is taking actually two arguments. First argument is a string, and second argument is the out parameter. That out parameter, let's say numerator. If this is successful, then it will return true. Otherwise, it will return me false. So let me give the out parameter num, and then let me check whether it is successful, whether it is failed. So I can have a check. If this is equal to false, means it is invalid. So I can return from here, or I can call environment.exit over here. This was my invalid numerator. Similar code, I will write it for denominator as well. So for denominator, we can have kind of copy paste for this, and we will try to take the denominator, and we will print the message that it is invalid denominator. If my numerator and denominator both are correct, then and only then I would go for the division. And if you wish that, or if you think that there can be a possibility that user might enter 0, if you are worried about that, you can actually write the if-else condition there as well. If denominator is not equal to 0, then I will actually do the division. Otherwise, let me print a simple message like denominator cannot be 0. Now I have written exactly same application once again, but nowhere I have used exception handling. From the efficiency point of view, you'll find that this code is more efficient even in case of the wrong input. Let me run it and you can check. What if user entered 10? I'm showing the error that invalid numerator. And what if user gave the 0 in the denominator? Again, I'm showing you the similar error. I hope this gave you clarity how exactly we can handle the exceptions in .NET. In this class, we started with some absolute basics like what is exceptions. We seen the very important exception classes. Then we talked about the basic syntax, talking about try, catch, finally, and throw keyword. We also talked about like exception performance. We talked about the user-defined exception class. We seen one important feature like C# exception filtering that was added in C# 6. I believe this is good enough knowledge for exception handling, which we will continue to use into our upcoming classes. Thank you very much for attending so patiently. See you in the next session. Bye bye.